Hello Year 12s. So today we're going to be starting with chapter 10, which is all about numerical methods. And the first section is called locating roots. Now I hope you've been covering all the previous work that we've set you. So I hope you've done independently chapter 8 and chapter 9, which is why I'm starting with chapter 10 for these videos. Okay. So let's just talk a little bit about why we are learning about this chapter. Now, numerical methods, there are several numerical methods which can be used to solve quite complicated equations. Okay, so you can't use your normal methods, which is, which could be factorization or solving by quadratic formula. Where those methods don't work, we then go on to use other methods such as iteration or Newton-Raphson method, which you're going to learn in exercise 10C, I believe. Okay, which is something new, but the idea of iteration and locating roots is something that you've done at GCSE. But this, here, obviously, you're going to come across more complicated functions, which might be in E form or logarithmic form, or you might see even trig functions as well. Okay, and that's obviously different to what you learned at GCSE. So let's just have a look at what this section is talking about. So we are going to be locating roots, and before we get into the example, I think there are a couple of different notations which I think you need to know about. So if you see something like this, we are talking about that x can take any values which are greater than a but less than b. So we are excluding. So basically these brackets mean that we are not including a and b. But if you see anything like this, then this translates to x is greater than equal to a but less than equal to b. Sometimes you might also see a situation like this, and this means that x is greater than a but less than equal to b. Or you might see something like this, and I'm sure you are able to work out that this means x is greater than equal to a but less than b. Okay, so in terms of notation, this is something new that you're going to meet in this chapter. Now the next thing you need to know about before we go on to the actual examples is what is a continuous function. Okay, so a continuous function is a function that doesn't have any vertical asymptotes. For example, if I was to draw a cubic function like this, this is a continuous function. Okay, but if I was to have a function which was, let's say, a reciprocal function that looked a little bit like this, then this is a discontinuous function. And it's very important to think about these when we are actually trying to solve problems where we're trying to locate roots. It's very important to think about what kind of function we're actually talking about. Is it a continuous or a discontinuous function? Okay. So the next thing is that you need to know about is that if, now let's say we are talking about a continuous function. Okay. So if the function f of x is continuous on the interval between A and B, and let's say that my A is here and my B is there, for example, and f of A and f of B have opposite signs, then f of x will have at least, now I'll explain what this means, at least one root. Okay, now here, if I was to input x is equal to a into my function, I would get a positive y value. If I was to input x is equal to b into my function, I would get a negative y value. So there's been a change in sign, okay? As I've gone from A to B, there's been a change in sign. I've gone from positive to negative. So what does that tell us? That tells us that obviously we've got a root between A and B. Okay, now, so at least one root there, which satisfies. Now watch what I do here, and you might all think, oh, why is Miss writing x is greater than a but less than b, and not x is greater than equal to a and less than equal to b? It's because we are looking for values between a and b, not at a and b. Okay, even though this says including a and b, but actually we are looking for roots between a and b. Now let me explain why it says at least one root. Now if I was to draw the same function here, I might choose my a to be there and my b to be here. And what's going to happen if I'm looking at this interval a and b? If I substitute a into my function f of x, I would get a negative y value. And if I substitute b into this function, I would get a positive y value. There has been a sign change, but there's not just one root. As you can see, there are 1, 2, 3 different roots, which is why we then talk about at least, which is why I use the words at least. Okay, because even though there is a sign change, it's not just one root, there are 3 roots, as you can see. Okay, right, now let's have a look at some examples which are extremely straightforward. Okay, so let's have a look at example 1. And example 1 says, the diagram shows a sketch of a curve y equals to f of x, as you can see there, and it gives us the function. Okay, so it gives us the diagram and it also gives us the function. Let me write that down. So f of x is equal to x cubed minus 4x squared plus 3x plus 1. Explain how the graph shows that f of x has a root between x is equal to 2 and x is equal to 3. So here, all we are going to say is that by looking at the graph, there is a sign change. Okay, when I substitute f of 2, this is what's going to happen. So all I have to, because the diagram's already given to us, all I need to say is that the graph crosses the x-axis between x is equal to 2 and x is equal to 3. So this means that a root of f of x lies between x is equal to 2 and x is equal to 3. Okay? And you all know what roots of an equation are. So if this was my function that they've drawn, and this is 1, this is 2, and this is 3, and it's a function which is a complicated cubic, as you can clearly see, this has got 1, 2, 3 roots. You've come across this since GCSE, so I don't need to go into too much detail of what the word root is. But here, between 2 and 3, the graph is cutting the x-axis. There will be a sign change. Our function is going to go from negative to a positive, which means that there must be a root between 2 and 3, okay? And this is that root that they are talking about, okay? This also could be, we can also say that this root is a solution, will be a solution to the equation where this is equal to 0, okay? So that's just another way of explaining what a root is. Part B says, show that f of x has a root between x is equal to 1.4 and x is equal to 1.5. Now obviously you can't see this accurately on the graph, so what we're going to have to do is we're going to have to substitute x is equal to 1.4 and x is equal to 1.5 into our function, okay? So you all have your calculators. Instead of writing f of x, I'm going to write f of 1.4 and then just use my calculator to substitute this in. And what's going to happen is I am going to get 0.104, which is a positive, and if I substituted 1.5, I am going to get minus 0.125. So when I substituted 1.4, which I assume is somewhere here, I'm getting a positive value. When I go 1.5, I'm getting a negative value. So the root that they're talking about is this one, which is between 1.4 and 1.5. And what I'm going to write is, and I have to write this explicitly in the exam question, that there is a sign change between 1.4 and 1.5, so there is at least one root between x is equal to 1.4 and x is equal to 1.5.